Hi folks, we're going to take a look at number 11 on page 386. So they give us the three vertices of a triangle and they want us to find the angles inside the triangle. All right, so see I drew a diagram and I made no effort to be accurate here because I'm just going to use the diagram as a guide. So in the past, the way we would have solved this is we would have found the distances between the 3 points, so found the side lengths of the triangle, and then used cosine law to find two of the angles, and then the third one we could just solve knowing the sum is 180. But what I'm going to do now to save myself a fair bit of time is use the dot product. All right? So the dot product allows us to find angles between algebraic vectors very easily. But of course, I don't have vectors yet. I just have the 3 points. So the first thing I'm going to do is I'm going to create vectors joining points. So, and again, I will put them tail to tail so that when I find the angle, I'm going to be getting the correct one. Okay, so by creating vectors AB and vector AC, I can use a dot product to determine the angle between them. Okay, so what I'm going to do here is I'm going to take AB dotted with AC. Okay, and that's equal to the magnitude of AB times the magnitude of AC times cosine of the angle between them. All right. So on the left-hand side, I'm going to use the algebraic definition. Okay. So first of all, I have to find AB and AC. So AB, so again, second minus first. So 4 minus 2 is 2. 11 minus 5 is 6. And then AC is just going to be negative 1 minus 2 is negative 3. And then 6 minus 5 is 1. Okay, and so here the magnitude of AB, well, I just found it, so that's going to be 4 plus 36, so that's root 40, times magnitude of AC, so 9 plus 1 is 10, and then cos theta. All right, so here theta is just going to be equal to cos inverse of, well, let's take the dot product here, so this is going to be negative 6 plus 6, well, just so happens to be 0 all over. You know, here I would bring this to the other side, so that would be square root of 400. Okay, but that's moot here because in the end, I just have cos inverse of 0. So that means theta is going to be equal to 90 degrees. So one of the angles in this triangle is a 90-degree angle. Okay, but whether it was or wasn't, the method for solving this would be exactly the same. So now I'm going to repeat this procedure for another angle. Okay, so here, let me now find the angle on this side. So I'm going to create vectors CB and then the vector CA. Okay, now notice here I can't use AC, I have to use CA because I'm looking for the angle between them. In other words, they have to be tail to tail. Okay, now having said that, because we found AC, CA is just going to be the opposite. Okay, so here I'll actually write it out. So the vector CA is just going to be the opposite to AC. So instead of negative 3, 1, it's just going to be 3, negative 1. All right, and then the vector CB, because we're using that one there, okay, is going to be equal to, so 4 minus negative 1. So 4 plus 1 is 5, and then 11 minus 6 is also 5. Okay, so now I'm going to repeat the process that I had here. So I'm going to take CA dot CB, and that's going to be the magnitude of CA times the magnitude of CB times cosine of the angle between them, which I called phi. Okay, so let's take the dot product of these two vectors. So it's going to be 3 times 5 is 15 minus 5, okay, equal to, well, the magnitude of CA is exactly the same as the magnitude of AC, so I've already done that. Might as well not do it again. And now the magnitude of CB, well, 25 plus 25 is 50. Okay. And now we can solve for phi. So phi is just going to be equal to cos inverse of, so 15 minus 5 is 10 all over, and root 10 times root 50 is just root 500. All right, so let's calculate that here. All right, so we've got inverse cosine of 10 divided by square root of 500. And that gives us 63.4 degrees. Okay, so 63.4 degrees. All right, and of course, to find the last angle, call it omega, I don't actually need to calculate that with any kind of equation because it's just going to be 180 minus 90 minus 63.4. Okay, so this is obviously going to give me 90. So 90 minus 63.4 looks like it's going to be 26.4. 26.6 degrees. Okay, 6 plus 4 is 10. 6 plus 3 is 9, 10. 6 plus 2 is 8, 90. There we go. So there's our three angles. All right, so just to recap here, in order to avoid having to do a whole bunch of trigonometry with the cosine law, what we do is use the dot product to find the angles that we're looking for. What was important here is that what they gave us were the three vertices, so we had to create the vectors from A to B and then A to C. So make sure when you create those vectors, you're using vectors that are tail to tail so that what you're getting in your equation is the correct angle. All right, that's it for this one.